An almost full, half-pie, waxing moon hanging lopsided in the night sky has long been a symbol of things to come. Now scientists have a new symbolism for the lunar phase we call first quarter, a looming risk of earthquakes. The moon is, mostly, responsible for Earth's tides, which are strongest when the sun and moon are aligned, during a full moon or a new moon. It's small, the moon, but so close that its gravity stretches and compresses the water across the globe, into high and low tides called spring and neap tide, respectively. It pulls on the Earth's crust too, but only a tiny bit, especially compared to the breath-like rise and fall of an ocean. Still, scientists have wondered for years whether the moon might play a role in earthquakes, which are essentially movements of the Earth's crust atop its mantle. It would make sense that the moon's gravity could tug at a fault in the crust, especially one that is already close to failing and slipping. But going back to the 1800s, nobody had demonstrated firm evidence for this. A new study gets closer to drawing this link. Studying data from the past 2 decades, Satoshi Ide and colleagues from the University of Tokyo measured the timing of high tides and reconstructed the amplitude of the moon's pull at those times, focusing on the 2 weeks prior to large earthquakes. They measured the amplitude of the tides against the timing of those quakes, and found some of the largest and most devastating earthquakes in recent memory happened when the Earth's crust was under the highest tidal stress. Ide and colleagues noticed the December 26, 2004 Sumatran earthquake, most notable for its horrendous, deadly tsunami, occurred near the time of full moon and spring tide. So did the February 27, 2010 temblor in Maule, Chile. These quakes both happened close to the peak of tidal stress, when the moon and sun teamed up to exert the greatest gravitational influence over Earth. The March 11, 2011 Tohoku-oki earthquake in Japan, which caused that country's devastating tsunami, occurred during the neap tide, but the tidal stress was high at that time. The study couldn't find any correlation between the tides and small earthquakes, but previous research has suggested there's a link there too. Nicholas van der Elst, a seismologist with the U.S. Geological Survey, published a study in July that looked at low-frequency earthquakes in the notorious San Andreas Fault, and found they were more likely to occur during the moon's waxing phase, which we're in at the moment, when the tide increases in size at the fastest rate. The mechanisms underlying this connection are not clear, however. The moon's pull causes tidal disruptions that are orders of magnitude lower than those experienced in an earthquake. And not every change in tide comes with an attendant earthquake. Part of the problem is that scientists still don't know exactly what causes a major earthquake. But one theory holds that they begin as smaller fractures that build up via a cascading process. We know from studying rock friction in the laboratory that the fault does not go from locked up to sliding in an instant. It can take hours, days, or even longer for the fault to really come unglued, even when the stress has exceeded the supposed strength, says van der Elst. The deep tremors that can lead to major earthquakes can be very sensitive to tidal stress changes, according to Ide and colleagues. The probability of a tiny rock failure expanding to a gigantic rupture increases with increasing tidal stress levels, they say. In other words, during a new moon or full moon, a small increase in tidal stress might be enough to encourage a very small fracture into a major earthquake. But that's only if the research holds up, as seismologists continue to pore over larger data sets. Ide and colleagues point out that at least 3 other quakes in November 2006, January 2007 and September 2007, were not correlated with times of large tidal stress. What about the next few earthquakes? We will have to wait and see, says van der Elst. Not all large earthquakes are caused by the moon's movements. But some of them might be, and so we do well to pay closer attention to the subtle yet powerful ways in which the moon exerts its influence on our planet, especially in regions prone to earthquakes. Scientists may have use for ancient omens yet.